sustainability. It's commonly called iteration zero in some of the agile parlance, but in general, things to do when you're starting with a new system. Who's ever participated in writing from scratch, from the ground up, a new piece of software? All right. And who's ever had a really bad, scary piece of software and you started a rewrite project? All right, this is everybody. All right. Now, both of them have some similarities. On the rewrite front, all the technologists have pretty much given up, and they report up, we can no longer really change this thing, and we need to just start over. Literally, we're wading through the code with mud on our boots, and we literally just can't change this anything anymore. We're not making any progress. It would just be better to start over. So what's too common, sadly, is a group gets budget approval or sign off from management to rewrite a piece of software, and it's rewritten, and then in 9 months to a year, they're slogging through with the mud on their boots again. Anybody been a part of the experience? You don't have to raise your hand. So it happens, whether it's a brand new piece of software or whether it's been around for a long time, that circumstances evolve and the software becomes hard to change, hard to grow, hard to modify. And when you're laying the foundation, and it's pretty concrete, when you're putting something in a new source code repository, there's some really important things to think about to set yourself up for success. And there's some pitfalls that if they're not addressed properly, then it's pretty predictable that some number of months down the road, and definitely by 1 year, you're going to be slogging through mud that we created for ourselves. Okay, and so that's what this talk is about. And my hope is that as a community here in Austin and as an industry, we can all get better and learn what things contribute to that slogging through the mud environment, and then do things specifically different to keep that at bay so that we can continually modify and support the software that we're building, and not get to a point where we are the cause of another developer's cursing because they inherited our code. All right, quick. I talked a little bit about what this talk is. What it's not is a complete deep dive on a certain technology stack to say, but we are going to be using C#, MVC5, .NET Stack, SQL Server, just as an example base. And this is a quick rundown of the agenda. We're going to go heavy into software configuration management, which is the biggest technical topic when you're starting a new piece of software. A little bit about me. I've got 3 kids. That's actually a 1.5 year old picture, but they still look cute as a button. And like off-roading in the Jeep down there, wrote a few books. And if you look really, really closely, you can see the HTML5 license plate. I figure I'm good until 2025, and then I'll have to change it to HTML6, but we'll just hold for now. You can go to my website, jeffreypalermo.com. I don't even have it on here. Or just Google me and find my blog and speaking engagements. So let's go on to the next. Oh, okay. Yeah, we're hiring too. All right. Why iteration zero matters. So you start a new project. I touched on this. This is so typical. You start a new project and everything's going great. And if you're using the Scrum methodology and burning down, you're going along and you're reporting that, yep, we're on track, yep, we're on track, yep, we're on track. And then at some point, there's an event that causes reality to no longer be ignored, but to be faced with. Sometimes on this graph, it's a QA drop. And that's when you have to bring everything together. That's when you do a test deployment to some pre-production environment. You deploy everything, not just a piece of it, but you get everything working. You actually have it integrated with what it needs to integrate with, and that's when you start to. That's when the deficiencies start to become surfaced. That's when you figure out the things that have been put off. That's when you figure out that the integration assumptions didn't work just right. Or that's when you figured out that the software that you built was perfect, but there was some stakeholder over here that needs slightly different perfect software and not the perfect software that we happen to build. And then we find new work. We might find all kinds of bugs. It could be technical bugs, integration bugs. It could be analysis bugs because there was a stakeholder that wasn't considered. Either way, we find new work, and now all of a sudden we're over halfway through our schedule, and we've been on track for more than half of the schedule, and now suddenly we're way off track and we're late. And how does this happen? Well, we're going to address the software configuration management causes for this tonight in this talk. Now, there's a lot of organizational elements that can also cause this, but tonight we're going to address the technical software configuration management elements. On day one, when you've got the development team together, whether it's 2 people, whether it's 10 people, and you're thinking about adding the first tiny little bit of code to a source code repository, what are the first things that we need to do? What are the first things that need to go into a new source control repository? That's what we're talking about today and drilling into today, okay? And that can set us up for a sustainable path going forward, or that can give us a foundation of mud from day one. So things to establish. Let me just frame it out. Things to establish when you're about to start laying code. And some of these you'll have been talking about way earlier. But of course, the project charter, or the problem that we're solving. And the problem comes with a definition of success. What is the mountain to be scaled? Complete clarity on what's being solved. That goes with any type of project. So just make sure we have that. If we don't have that, okay, put the source code repository away and let's go get that. And then the solution. How do we finish it? How do we solve the problem? There's nothing technical in this, but just the general approach to solving the problem. The basic shape of the software that we might happen to be building, and that is the solution. And the solution typically should be devoid of any technology selection. The solution could be, an architecture for that solution could be developed in the Java stack, the LAMP stack, the .NET stack. It's just the approach to it. And then the architecture is, okay, let's do technology selection. What are we going to build? What are the libraries? What are the frameworks? What are the dependencies that we're going to pull in? And then with an understanding of what we're building, we need to figure out how to build it, what the assembly line is going to look like. Because when we're on a software project, we're essentially creating a manufacturing plant where we are cranking out software features. And there's a flow of features that go through this plant. And we need to figure out what the stations of work are and what the inputs and outputs of each station are. And then, okay, we churn out all these features, and then after that is the DevOps piece, how to run it, version it, secure it, manage it going forward. So we're going to dig in deep again into the architecture piece and a little bit of the software development lifecycle, and that's the focus of tonight. Okay, that's where it fits in. All right, so diving straight into the architecture. These are the things that are expensive to change. They're non-reversible decisions. There's tons of design decisions that we're going to make. There's tons of design decisions. A lot of them we can learn, oh, you know what? It's not quite as appropriate, and then we can change it. We can reverse ourselves. In the software world, the materials that we're working with are very malleable. We can change things out. And so architecture are the non-reversible decisions. So there's certain design decisions that if you want to change it later, it's going to be hard, it's going to be expensive, it's going to take a long time. So that's the demarcation that rise to the topic of architecture. And so obviously choosing the .NET platform versus Java, that's one of those things. What type of system you're building. Dependency management is one of those architectural decisions that we sometimes overlook, and I'm going to drill into tonight, because oftentimes a developer will be developing a feature and then go reach for NuGet and drop in a new NuGet package, not thinking, I'm actually introducing a dependency to my software. So we'll drill into that. All right, so software configuration management is a topic that, in my view, isn't talked about enough, but it is the crux of this iteration 0 process. All right, and there's a book, Configuration Management Best Practices, and it's got a yellow subway on the cover. Anyone read it or seen it or touched it? Okay. It's a very good book. I recommend reading this book. It covers the 6 pillars of software configuration management. The first 3 are relevant to iteration 0. The source code management, build engineering, environment configuration. The last 3 are important, but those are different topics. You're not going to tackle those and complete those in the first iteration. Change control, release engineering, and deployment. But I highly recommend this book for those of you who haven't read it yet. All right, now, who's heard of continuous integration? Most of the people in this room, because it's been talked about for almost a decade. The book that's right here on the screen was published in 2005. I think late 2005, if I remember correctly. So it's been published in book form, readily available. The 5 years, 2000 to 2005, there's a lot of talk and a lot of discussions in the industry figuring out how to rapidly integrate to get to a point where you could say, oh, do you have CI hooked up to this? And it actually meant this collection of practices. But since 2005, we have this book. And so as an industry, we're almost a decade in where there's a published work for how to do this and what it means. And we've all heard I hope that we've all heard the topic, integrate early and often, and getting frequent feedback from your system and reducing risk by doing everything in the small and doing it all the time, continuously. So there's a quote that I'd like you all to read, and I'm going to let you read it here for a second. Please read it to yourself. So this was the foreword to the continuous integration book written by Martin Fowler. And what it essentially means is, as an industry, integration has ceased to be a problem without a solution. We've got it solved. What it means is, for those paying attention, for those learning what is available in the industry's body of knowledge and putting it to work, it's a solved problem. And so iteration 0, this continuous integration, is part of the build engineering pillar of software configuration management, and it's so critical, and we'll dive into the mechanics of that, build script, the steps, and all that as we get into the actual code in Visual Studio. But I just wanted to stress what is available out there in the industry, and it's just up to us as practitioners to learn not just from our teammates, not just from the people that we might have worked with prior, but learn from the other people in the industry who've figured out these problems and published things. So the goal of iteration 0, here's the goal. No features. We don't need any sort of software features. We don't need to pull a user story and actually get an actual screen functional. But the goal of iteration 0 is to have in place a process where multiple developers, and I don't know about you, but developers at my company, they all look like this. Multiple developers can all have a working copy of the source code on their box. They can make changes. They can push it into source control, and an automated build will automatically spin up, will, in an appropriate environment, configure the environment, run through a build process, a series of steps that you define. That means this step forward was a very safe and positive step forward in the software, and I have not introduced risk. And once that happens, create a deployable, releasable package of some sort. Zip files work great for some pre-production environment. And if any problem is detected, stop and send feedback to the team. So that's the goal of iteration 0. Now, what it forces you to organize your source code repository in a certain way. It forces you to create the appropriate Visual Studio solution that's representative of the shape or the architecture of the system that you've decided to build, with thin, ever so thin vertical slice of the architecture that you've chosen. It forces us to set up a build server for continuous integration. It forces us to create a build script where we are going to enumerate what our definition of a good build is, and it forces us to package the application in the shape of the architecture we've chosen into a format that is suitable for deployment. And it goes all the way up to, and sometimes, depending on your environment, you'll choose to actually hook in a automated deployment at that time, or you'll choose to defer it to, but very soon in the project. But it forces us to do all these things, because when we do all these things, adding features is that assembly line. Once we lay this out, we're laying out a whole process for how we're going to be modifying and testing and evaluating the code all the way up to creating new versioned releasable packages. And then once we get to this point, it's just turning the crank. Turn the crank, add a feature, add a screen, add a feature, add a screen, and then you can go, go, go. If we shortchange these elements and we start to add a feature, then we're constantly tripping over each other. We're constantly walking through our own mud organizationally and with missing things in the code. We're on week 2 or week 3 and we're doing a feature and we're tripping over, and then someone says, hey, wait a minute, we should go ahead and hook up a build script. Oh, well, we don't have time this week, maybe next week. Because now we've gotten into the feedback loop with external parties, and frankly, it squeezes out what we should have done already. All right, so actually I already talked about this, but I'll just go into the next one. All right, so we're going to jump into the version control system first. Last slide before I actually jump over and show you guys, actually 2 more. Locking and non-locking. This is less of a discussion these days because of all the options for version control. Anybody who looks around, just whatever position we had before, Git has one. That's it. Just reality. Regardless of what each one of us thinks, for the longest time, I preferred Mercurial over Git for the longest time. But regardless, we just have to recognize in the industry that Git as a source control technology has won. And Microsoft says, yeah, Git won. Okay, we'll put Git in TFS because we still like TFS. So in order to get the people that they want to use it, they put Git into it. So Git has won. So the non-locking form of version control has won, has sort of become the de facto accepted modern source control management techniques. Now, the stuff leading up to this point is going to be around for a long time to come, but going forward, it's just good to recognize how the industry has changed. And so the locking versus non-locking is a different worldview. In the locking sense, we think code is difficult or risky to change. So if I am inside of a code file, I don't want anybody else touching it, modifying it until I say that I'm done with it. In the non-locking perspective, anybody can be modifying anything at any time, and we trust that our infrastructure is going to be able to handle any merges, any conflicts, and be able to quickly undo somebody's misstep. And it's more decentralized in nature. Okay, but it is a different worldview, and the non-locking has largely been accepted as a whole. Whereas I do recognize over the last 15 years, the debate has raged, and the industry has transitioned from 15 years ago. Clearly, everyone was in the locking camp, and CVS and then Subversion started the heated conversation. And now, as an industry, we're on Git, we're on non-locking distributed version control. So I'll be using that in the presentation today. So we're going to dive into it. When you're about to lay code down in a source control repository, first thing we have to think about is where are we going to put it, right? Now, without making these decisions, what happens too frequently is we look back on what happened and we see a source control repository that sort of says that it's a source control repository, but it really looks like a network share. It really looks like you might just map a drive letter to it, and it's just a whole lot of folders with a whole lot of stuff, and you need to search for the stuff. And maybe you have one folder with one thing over here, and maybe you have multiple Visual Studio solutions, and they're just there. Okay. Now, who's ever seen that type of thing where you just have a whole lot of disorganization in there? It was somebody else's software, I'm sure. But when we're approaching the source control repository, first thing we need to do is choose our branching strategy. We can choose to have no branch and just have one main line, and that could be appropriate if it's something simpler, we're working by ourselves. We have found Git flow to be the most comprehensive pattern for branching these days, and we tend to use that at ClearMeasure. We do tons of software systems. When we inherit a system, we overhaul the Git repository to apply Git flow, and you'll find for folks who want to read about it, the debates, really sophisticated teams will progress from Git flow to feature branches if they do real continuous deployment. Whereas if the build passes, it's an automatic push to production. Most of us in this room and most of us in the industry have a human decision about when to go to production, as opposed to just having some automation constantly pushing to production. Is that fair? Is everybody in the same boat? Okay. So, for instance, the actual GitHub team, they do feature branching, but they also automatically push to production as soon as it runs through the gauntlet of automation. But most of the industry, we will do that up to a point in a pre-production environment, maybe to staging or some pre-production environment. We'll just constantly refresh. But we really stop back and kind of look each other in the eye and say, okay, we're going to go forward in production with this named version. Everybody good? And we'll decide and we'll go forward. That's most of the industry. So for that most of the industry, Git flow is the most appropriate concept, and I'll go through it real quick. So the blue line is your master, is your trunk, is the main line of code. And with Git flow, the commits in that line are versioned numbers, and you can tell that there's one commit for a version that could have been deployed to production. There's various ways to branch. They're listed at the top. There's a hotfix branch, a release branch, the develop branch, and feature branches. The develop branch is the main branch that most everybody hangs out on and synchronizes while we're developing the software. And so that's this purple one down here. So I'll go through a scenario. We're developing a new feature. We create a feature branch off of develop. And then if there's one person, if there's two people, if there's three people working on that feature, for the life of that feature, or for the process of developing that feature and the automated tests to go with it, we're going to be on this feature branch down here. And there could be as many commits as we need because we're working on a feature and we're isolated from the churn going on around us. Now, same old rules of source control apply. We check in multiple times a day, and we never go home with code only on our box. Never go home with code only on our box. Who's heard that from anybody else in their career? Oh, come on. I'm trying to get some audience participation here. All right. So everybody's heard that. Everybody's heard that, right? So with branching, just because it's my branch doesn't mean that I can break the old time-tested rules and have code that's only on my box. Push the branch. It's still your branch, but push it up. That way, if your computer dies, the code's still there in your branch on the server. Okay. Same rules of source control apply. Never go home with uncommitted code. So that's a feature branch. Here's another feature branch that's created. You can have as many in parallel. When the feature is complete and it's reviewed, your process of yes, it's good, then that branch is terminated and merged back into develop. Okay, and here it is. In the meantime, there's a bug that's found in production. We create a hotfix branch from master, which was the version that was in production. We create a hotfix branch, we fix the bug, and then we terminate and merge that branch back into master. And then we have version 0.2 here. We can deploy that back to production. Okay. Now, meanwhile, development's going on. and we're ready. At this point, we've got enough features. We're ready to actually go to production. And so we're going to make a release branch. We make the release branch because we want to update the docs, rev major and minor versions, other stuff that we do to prep for an actual production release. And so we do that on the release branch. We not only terminate that back into develop, but we terminate it back into master, and then we can go forward. Okay. Now, tenets of branching is you never want to get too far away from your parent branch. So even though these feature branches might go on for some time, it's up to the owners of those branches to constantly be back merging from develop, from its parent branch, so that the termination merge back to it is really, really easy, so that you're not too far away from the parent branch you came from. Let me show you real quick Atlassian source tree. And what I'm showing you is the iteration 0 repository. It's on GitHub, github.com/, there's a GitHub organization, clear measure, and this iteration 0 code base is there, so you can get all this code. And it has, I've gone through the motions so that you can see what it looks like as I made some changes giving this talk at the Houston Tech Fest conference. And I'm going to zoom in a little bit. So you can see that we have the develop branch, and off the develop branch we have a few feature branches that are live, and we have a release branch, and just the remotes are below. It's the same. You can see in the commit log what it looks like, and we have the master, we have develop, feature branch, merging it back in. What I like about this tool is if I go to my working copy, I can click on Git flow. And when I'm ready to start a new feature, I just click the button, start a new feature. Who loves Git command lines? I don't, actually. And we can use Tortoise Git or whatever tool we want. Tortoise Git's probably my next favorite behind this one. But Atlassian source tree is a free source control tool, and it actually has incorporated the Git flow pattern into it, so we can just click buttons and say, hey, you know what, I want to start a new feature. Oh, well, what does that mean? Well, that means I need to do a branch operation from the develop branch and name it this and put it in the features folder, and then, well, let's just create one. Actually, it's not scripted, so let's not create one. Never mind. So I didn't clean up and sync up this repository, but it also has buttons to other actions like finish a feature. I'll zoom in for you. Finish a feature, finish a release, finish a hotfix, because those involve merging the branches back in. Okay, and so it's a pattern supported by tooling that makes it just really easy, so that we can think about what we're doing instead of what combination of three command lines would be appropriate. Like if you do rebase, then merge, then check out or whatnot. So all right, so that's Git flow, and that's the organization of the repository from a branching perspective.
Question.
Yes, sir.
How do you rebase through that tool? That source checkbox.
So
What was that actually?
rebase development branch.
Oh, okay. Thanks.
And with this branching pattern, you can think about when you want to rebase and when you don't, because oftentimes in the history you want to see that you branched off to the side and you had a bunch of commits and maybe two feature branches going at once, and then they both went into develop at separate times. If you rebase, then you don't ever have that actual history that you ever created the branch. So, but you do have that decision to make. All right, so let's here. All right, so next we're going to talk about the actual solution structure, and we're in the develop branch. We click add feature, and the first feature we're doing is, and it's okay if you don't add it for this, but iteration 0 code, right? It's your initial commit. I'll come back to this in a second. So inside source control, this is the root of the working copy for iteration 0. These tenants seem to be pretty stable across lots of different types of software in the Microsoft space, and have a lot of similarities with some Java roots as well, with like the old ant and make processes, where you have a source folder so that all of your code starts one folder down, as opposed to putting your Visual Studio solution file in the root, in the topmost. And that is so you can actually have a place to write some scripts to do some things. And with your code one level down in that source or SRC directory, it gives you some surface area to actually create some helper scripts in your build file. Okay, so I'll show you this in a second. Default.ps1 happens to be the build script for this code, and then we have some simple things like open.bat, which is all it's doing is shelling out to Visual Studio to make it really easy to, you hammer on this and it opens up Visual Studio 2013. Okay, thanks for loading my user settings. And then click to build.bat. I'll just run it. It opens up a command prompt and it runs our build script, which is in the Saki PowerShell format, and it has a ampersand pause at the end so that if it fails or succeeds, it keeps the command window open. So that if you didn't have that, then it would just close and you wouldn't get to see what it does. So I'm going to come back and actually go through the steps that this build script executes, but I wanted just to show you what the experience was like to just, hey, run a command and it's doing all the environment configuration, it's doing compilation, it's dropping and creating a brand new SQL Server database right there on the local box. It's running some unit tests that are in process in .NET. It's running some integration tests that include running queries against the database, and then it's dumping some test data into the local database so that when you go to Visual Studio and hit Control F5, run the application in Visual Studio, you have enough data in that database to where it can actually run, because no application can even run, very few, if there's literally 0 records in every single table in the database. So those are the typical steps. We'll come back to it. And build succeeded, yada yada, with some timings. We'll come back to the steps there, but I want to show you what else is in. ci.bat, that's the helper batch file that we use to hook up JetBrains TeamCity, and it runs the CI target. JetBrains TeamCity, who uses it, by the way, TeamCity? All right, so I'll say this just for the benefit of you guys, and for the rest of you. TeamCity is free up to, I think, 10 or 20 build definitions or something like that. And so if you have one piece of software, it's free. You're not going to outgrow it. And what you can do is you point it to your source control repository, whether it be on GitHub, Mercurial, Subversion, TFS, any of those, and it's going to watch. And every time it sees a change, by default, it's going to look every 60 seconds. Every time it sees a change, it's going to kick off whatever you tell it to kick off. And you can build your build process using your mouse, and you can click around, and you can have it just do Visual Studio. But the best practice way is to have it execute a command line. And the command line that we configure it to execute is ci.bat. In other words, get my source, plop it on a local directory there on the build server, and run ci.bat, which is right here. What that does is it makes sure that everything necessary to build the software is in the source control repository. TeamCity and Visual Studio Online and Final Builder and other products that have been around for a long time as well have the ability to define the build workflow on the continuous integration server. And that's great, but what that does is it takes the process to perform the build of the software and keeps it out of your source, because you're putting it on the build server. And then as you go and change it, you lose the history of what it used to be, and that precludes us from being able to go and get an older version and rebuild if we need to do a hotfix or whatnot, because now we've changed the definition of what it means to build. And so by having the build server just run a command line, it guarantees us that if we go back to do a production hotfix, go back in time in our version control, we've gone back in time not only in the code and the definition of every CS file and JavaScript and HTML, but we've also gone back in time in the definition of our build script so that everything is completely in sync. We haven't lost anything. So if it's required to build and make and manage your software, put it in version control. That goes for everything.
That's the use of the database.
Absolutely, absolutely. I'll show that as well, and that includes NuGet packages. I'll go into that as well. All right, so 7-zip. That's just a few utilities. To make a release package, we needed a command line that can actually zip something up that's reliable, and so we put in 7zip.exe. It's a whopping 524K, and it works great. So if it's needed, put it in here. If you have one of those sysinternals tools that you need to use, stick it in here, right? Disk space is cheap and probably much smaller than some of the graphics on the website that you might have in that version control system. So let's go into source. And we can see that we have our solution, Visual Studio solution. Let me zoom in right there. This happens to use, in Hibernate, there's a config file, commonassemblyinfo.cs. I'll show you that in a minute. And then we have projects for each one here. Let me switch over to Visual Studio. Okay, so let me show you a diagram of this particular piece of software. Let me zoom in. This is the diagram of the dependencies, and this is very important. So important. You got your source control layout, you got your automated build, but how to structure the Visual Studio solution. Who here has ever taken a course in how to properly structure a brand new Visual Studio solution? Nobody. Why? Because it doesn't exist. It's not on Microsoft's documentation. It's not taught in college. It's not taught in any curriculum I've seen. Nobody teaches it. Why? I have not a clue. But that's one of the reasons that I like to give this talk, because it's so necessary that we think in a structured way about how to put together a Visual Studio solution. What happens is we don't think about it, and we do file new. Hold on, I'm on a roll here. So file new. Great. All right. So brand new. I'm going to create a new project, right? I'm really excited. Well, look here. What I like. Do I want to create a project or a website or a team project? Which one is it? All right. Well, let's pick project because we never use any of the other ones. And then what do I want to create? Well, okay, none of these make sense. Today, most of us typically are on the web. And so, all right. Well, I guess I'm creating a web application. No, you're not. You're creating a financial system that has tons of transactions per second flowing all over the place, and it happens to have a little website over here, but it has 3 different Windows services over here. Visual Studio has no way to ask you what you're building. It asks you, what UI technology would you like to couple yourself to today? That's what it's asking us. So this particular feature is geared to the, okay, let me get started in 60 seconds or less. And the old demo of, oh, click, 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 boom, double click a button, type something in, Control F5, look, ma, no code, right? So so it's really, really important that we think intentionally how to structure our Visual Studio solution. Again, these are the things that we're doing in the very first week, maybe 2 weeks of a project. We're doing the most important things that if we neglect these, we're setting ourselves up for hurt. We're setting ourselves up to slog through the own mud that we created for ourselves. Okay? So dependency management is a really, really critical topic. It's important that we think very intentionally about how to structure the dependencies. Let's see. Anybody create code in the 90s in the desktop era, where everything was a desktop application before we went to the web? Okay. So we had 3-tier was the big topic, where the desktop was a pretty significant tier. There's a lot of code running on the desktop, and it was 32-bit, and it was VB6 or it was Delphi, but it was a big desktop application, and we took great care and great effort to deploy it properly. Then, in order to prevent every desktop from having a direct connection to our database server, SQL Server 6, 7, whatever it happened to be, or an ODBC DSN to the back office mainframe. In order to prevent us from having that direct connection string, we said, you know what? Let's put something in the middle, that middle tier. And so then there was a big COM Plus movement where we could install a C++ or Visual Basic 6 COM Plus DLL, install it as an application running on a server that was centralized, and then through the binary remote protocol that was COM Plus, we could have our desktop applications communicate directly to that server, put that sort of a firewall off, DMZ separate, and then that was exposed, and then the COM Plus, the code that was inside the COM Plus application was what called the database. And so we had this 3-tier: desktop, COM Plus, and then SQL Server. Well, in the web world, we then said, okay, well, guess what? We don't have to deploy desktop anymore. Right? Jump up and down because it was really hard. And instead, we have the whole application running on the server that used to run just the middle tier, and then we had the database. Okay, that's great, and it actually works really well. But from a dependency management perspective, what happened was we took. Well, let me back up just a second before I go into that. We had dependency problems in the desktop days as well. Has anyone tried to update? Has anyone had the task of updating one of those VB6 desktop applications? All right, if you're like me, you go in there and you say, all right, you know what? Let's just kind of take the screens, the UI code. We've got business logic. We've got all this COM Plus layer. We've got this one, and we named it business logic layer, right? So we've got all of our business logic nicely factored in this COM Plus. We've named it business logic layer. So we take the VB6 code and we slice off the screens, and once we slice off all the code that's intertwined with the UI, the buttons, the text boxes, and everything that was user interface centric, we surgically slice it off, and then we look at it and we say, yeah, I just took off 80% of the code. Why? Because there was no separation between the UI and everything else. And we find that the COM Plus, the business logic layer, was actually just some dumb functions, and all of our logic was coupled with the UI anyway. Why? Because we didn't think about dependencies, and we just coupled the code that was talking to our user interface controls was the same code that was really executing our business logic or intertwining it all, and we didn't actually separate it. So fast forward where we're on the server, we still have the same issue. We still have to think about it intentionally, because if we don't intentionally separate our dependency, I mean, this is the same topic. This is layering. This is layering. This is dependency management. This is separation of concerns, principles that a lot of people talk about, but this is the concrete way to actually implement those concepts that are written about in a Visual Studio solution. We need to keep the business logic out of the UI and keep the UI out of the business logic. We need to keep the business logic out of our data access or storage code and keep the data access code out of our business logic. And so what we find conceptually is we have the UI over here that we know in 5 to 10 years is going to be thrown away because that's what we've always done, because the UI continues to change. We had a pretty good 8, maybe 10-year run where we could develop web applications for the desktop or for full screen sizes, and now we can't do that anymore because the mobile trend says, yeah, you can still do stuff for the web, but it's a different screen size. And so even web applications that were built 5 years ago, that UI approach is obsolete right now just because of the different screen sizes and the responsive design that goes into some automated resizing and hiding some things. Just that approach is enough to have some people completely rewriting their web applications that they built just 10 years ago. Rewriting web applications with what? Another web application. Because they find that they didn't separate the dependencies from the UI that built those pages to code that's going to build pages in a slightly different way, because they didn't separate the dependencies. So we have UI over here, we have data access over here, we have integration over here, we have maybe web service calls out to a third-party system over here, and so we have tons of things in the periphery that are dangerous, They are dependencies that we don't know when they're going to change, but we need to keep them at arm's length. Then we have our system in the middle, and we want 80% of our code to live more than 10 years. So we need to have this nucleus, this core that we need to protect. And we want to put that in some large system sizes. You need to segment out into multiple applications, and I'm not going to go into when that happens. But you can go a pretty long way with this type of Visual Studio solution structure, where you have a core project that in the end creates a DLL, call it core, and you want to put 80% of your code in that project. Then we have a UI project. Okay, put screens, try to make it as thin as possible. Then an infrastructure or a data access project, and you want to just do queries and data access. Here's the key. Infrastructure, make it a project reference towards core, not the other way around. I've got some blog posts on my website, jeffreypalermo.com, talking about onion architecture. And that pattern, people are implementing that pattern all over the country. If you search, you actually see a lot of people using it because it's the instantiation of the separation of concerns that everyone's heard about, but it's hard to get down to the concrete steps of, okay, I'm in Visual Studio, now what do I do? All right? So this solution structure can get you really far away. The crux of it is you come into core where you're saying, you know what, we're going to put most of our code here. We're going to put our domain model. We're going to put core application services that don't have any. We're going to call other code to actually do queries, other code to build screens. But this is the inside of the application. Look at the references for core. The more dependencies that we reference, the shorter the lifespan for our software. Now, Visual Studio doesn't help because when I create a new class library, it references like 9 or 10 assemblies for me right off the bat, including system.data.stuff, right? For a class library, they might create for a calculator app. You got system.data in there. So when you're creating iteration 0, you want to start clean. You want to start with the infrastructure. You might add a reference here. But iteration 0, when you're laying down just the foundational pieces of structure, just these, buddy, just these. For these to change, you would have to abandon .NET itself. Okay. Now, let's pick on UI technologies. .NET 1.0, we were writing web applications using absolute positioning with the grid designer. And then .NET 1.1 came around and said, okay, let's go back to Flow. And then .NET 2 came out, and UI paradigms are changing again. And there was a certain time when the designer had these components in it, and then MVC comes out, and now we're not even doing web forms anymore. Big shift. UI is changing. Now, next year we have another ASP.NET refresh, where even though it sort of looks like MVC, MVC 6 is the web API stack, not the system.web stack. So all of your applications written with MVC 1 through 5 have to be ported up to MVC 6 with sort of manual backwards compatibility, compatibility by convention instead of binary compatibility, which they've been able to do because there's a different runtime in .NET. So the UI continues to change. Data access. Who remembers doing data access and using, what is it, Enterprise Library? Remember that one? And then link to SQL and Entity Framework 1, 2, 3, 4, 5, 6. But Entity Framework 7 is a complete rewrite with no backwards compatibility stored in Entity Framework 6. I'm sorry if you're hearing that from me for the first time. But you can go online and they've announced it. So data access, all these stuff that's on the periphery, they continue to change out from under us, and we can either be a victim of it or just recognize that, guess what, that's the way the world has always been. People who create really awesome libraries and frameworks for us to use, they're going to change it, they're going to version it. We have to decide what's the really important code that's part of this system that's going to carry us forward 10 years, 20 years, and it's well factored, and what is the code that, because it is leveraging and integrating awesome frameworks and libraries, it's going to just be thrown away whenever those awesome frameworks and libraries happen to change. Because that's just reality, and it's that way. And the project references are the concrete manifestation of integrating those dependencies. If we have a reference to it, we are coupling our code to it. Okay? So any developer just deciding, hey, you know what? Let me just pull down this NuGet package. Let me just add this right here. Why? Because it's useful. That needs to be a carefully considered decision, because we are only as stable as the code that we couple ourselves to. Yes, sir.
What's your thought on service architectures? So you have like a lot of internal services. Do you still have a core DLL with your business logic, or that's shared between all your services, or what's your stance on that?
Good question. So let's see here. This one really. All right. So let's say I visit a repository. You could, if you define an interface that defines the conceptually what this thing is, yeah, you put your interfaces in core, and then the implementation, the class that implements that interface, it can be anywhere. And if the code that implements that service interface happens to need a library, well, you can have that be on a separate project and reference core, implement it. That code can be completely coupled to this other library in the implementation of the interface, knowing that, okay, well, if that library changes, then we're going to lose that code. But the concept of what it does and what purpose it serves for the application, that's stable, and that's really what matters. And I can change out the implementation at will without having changes ripple through the rest of the code. Like, in short, yes. All right, so core example, we have iVisitor repository, and in infrastructure we have inside data access visitor repository, and it implements the interface you see here. Why? Because in references we have, by the way, this infrastructure project, you see how many things it references? What if this stuff ceases to be useful, doesn't get maintained, we need to change that for something else? The stuff in this project, yep, largely going to be rewritten. But we've designed this project to be expendable. So we're okay with that because we've kept it really thin. And the code here implements the important interfaces in core, and we've intentionally decided to do that. All right. So dependency management, the structure of the project references in Visual Studio, so important to get right in iteration 0. Because if we don't get it right, what happens is we have our UI project. UI project references a core project or a business logic project. That project then would just accidentally reference some other project that's doing the data layer, and then that's, of course, tied to the data store. And so all from the UI, we have waterfall references all the way down. And who's heard of the transitive property in mathematics? Where 1 plus 2 is, 1 plus whatever, Same thing with project references. If A references B, and B, well, if A depends on B, and B depends on C, then A depends on C. Okay? So if we have a UI that references a core, that references data access, that's coupled to SQL Server, why separate it at all? Because we're just flowing right through, right? So, iteration 0, think intentionally about how to put together that Visual Studio solution. Protect the structure of your dependencies, because that is going to be the health of your software. Okay, so let's go back. I wouldn't be losing my voice if I didn't care about this stuff. Brings a tear to my eye. All right. Okay, building software, continuous integration. We've got source control, we've got Git, we've implemented the Git flow branching model. We've created our develop branch. We've laid down the first files. We've created our source directory. We've put a properly structured Visual Studio solution in it using the onion architecture principles, managing dependencies, selecting the technology selection that was appropriate for the architecture that you chose for your system, and then we're coming back and say, okay, now we have a Visual Studio solution. I didn't go into it, but we have test projects, integration test projects. Let's go ahead and put together our build script. That'll go at the top. All right. Before I go to that slide, let me just pop back to the top of the working directory. Let me open this up. Let's see. Open with PowerShell. Where's that PowerShell ESI? Okay. Okay, well, let me just open it in something else. Okay. All right. So this is a Saki build script. Is this text okay, or do I need to zoom in and zoom out? Okay. All right. So this is a Saki build script, and it's actually the same build script that I posted on my blog. I've been maintaining a build script template since about 2009, I think, or 2008. It started with NANT. I personally really got into complex, well, not complex, but comprehensive build scripts using the NANT technology, which was, who used NANT? Sort of the XML, executable XML, came from the Java Ant heritage. And with PowerShell, a gentleman named James Kovacs created essentially a conceptual NANT port implemented in PowerShell, where you could take the same concepts, which would have been vetted over time as being meaningful, and you have certain targets or tasks that can execute and can be declared to depend on another, so that you can execute any of them, and they'll make sure that that the build script framework executes the steps that it's dependent on in order. So this template, it's on my blog, or you can get it from the Iteration 0 code base. Please take the code base on GitHub, take it, use it, benefit from it, hack it up, steal a file. Just let me know if it's useful to you, because that's the goal of open source, right? So this build script, I'll scroll down just a little bit. The bottom here, we have two main tasks. One is the default, which is the private build, which is everyone runs locally before they check in to make sure that they're not going to break the build if they just commit what they have, and it runs all the same steps. The CI task, or target, is for the build server itself, and it typically, your continuous integration target does all the same stuff except a little bit more, and in this case, it does everything the same except creating a package, okay? And I'll go through initializing it, creating a common assembly info, which I'll talk about in a second, compiling, rebuilding the database, running a test, a suite of tests, and then loading data. And the bulk of this, if you use a Visual Studio solution structure similar to what's in this software, by the way, you can just take this entire source code repository of Iteration 0 and just start hacking it up and make it into your own application, and all this stuff is automatically wired in for you. The rest of this build script is largely boilerplate if you follow some of the simple conventions, and all of the things that change from code base to code base have been elevated into properties at the top and just made PowerShell variables. Now, I guess I've been in a unique situation. In 2005, there was a startup company that ultimately failed because nobody sold anything. But so in 2005, and 2005 continuous integration. I mean, that's when the book was written. That was cruisecontrol.net days, hot and heavy, right? It was fun times to be in the extreme programming agile world. And so it was coming out. We had NANT build script, a lot of these topics. If anyone knows about the Tarantino database deployer, which has now become AliSQL for database migrations and a whole lot of other stuff. We carried that forward, and then I started professional services, did a small company, and then rolled that into a company called Headspring for 5 years, and then branched off and now running Clear Measure, which is now a 36-person company. It will be on January 5th. We're a software engineering firm, and we do tons of different pieces of business-critical software. And so we're constantly creating, upgrading, and going from project to project. So some of the things that we've done has allowed us to optimize the iteration zero process, because unlike some teams that go through that process once every couple of years, we do it all the time. And so it sort of forced us to really get good at laying down a new source control repository. And related to that, a new build script. And so the boilerplate stuff is below, and the properties are up above. And so we have the project name, which is essentially the Visual Studio Solution file without the .sln. What is the unit test assembly? Because we need to have one. What is the integration test assembly? Because we need to have one. And what is the full system test assembly? Because we need to have one. And these are just in-unit assemblies. I know there's a lot of other test frameworks out there, but in-unit has one. It's the most widespread, most widely supported one. So project config, debugger, or release. Some paths here. You know, source is the source directory. Where do we find in-unit console.exe? This path. Where do we want the build artifacts to be put? There's a few things about ignoring _resharper, because just out of convenience, it tends to put a lot of stuff that doesn't need to go in part of the build process. Excuse me. And then something about the database server. We have a convention that we try to target our software to run on SQL Server Express, because if it's compatible with SQL Server Express, then we can really deploy it on any SQL Server version we need, and it forces us to make a decision. If we need to actually use a feature of SQL Server Standard or Enterprise, it forces us to intentionally make that decision and change it here, as opposed to maybe accidentally doing something that couples us to one of those versions, but maybe we didn't need to do that. So we start off with SQL Server Express, and then when and if we need to use one of the features of the other versions, it'll force us to intentionally make that change, because of course it won't run if we try to. So and it's just easier that way. Okay, most software can run on SQL Server Express from an application perspective, and then maybe use SQL Server Standard or Enterprise for some of the SSIS or EDI features around that. But as far as the .NET application itself, you can get a long way with just the feature sets that are supported in Express. Okay, because we've got but again, we do lots of software, and so we've got this convention of doing SQL Express 2012 or SQL Express 2014, putting the actual version number, because if we have 20 different code bases and jumping from one to another, if it's built for 2014 using some of the new RAM-based tables versus 2012, we want to keep that separate. And then where the scripts are. So let me scroll down and go through some of the interesting ones. We're going to do a compile, which is a msbuild.exe clean and then build on the solution. We have a test target that is executing in-unit console.exe on the test assemblies. We have a rebuild database, which is using the aliasql exe to literally drop and recreate the database from the database change scripts, which are right here. We have a database project. It has the database project. It has the scripts right here. So we have, for instance, update scripts, and they're in order alphabetically. We put numbers in the front. So the first thing we do is create, in this case, a visitor table. And then the next thing we do is add a column to it, which is here. And because, here's the difference. If we script out a database and put it in source control, and it has the definition of a table, in order to add a column to that, we have to modify an existing SQL script, but then that's the create table script. So it's difficult. If we have a set of scripts that create it from scratch, that's interesting, but it doesn't allow us to progressively update and change the database. If in source control, we instead of storing the comprehensive set of scripts in a snapshot, instead, if we do that first, And then subsequently, we store scripts that are changes, that are updates to the schema, that are alter statements. If it's a store procedure, that we can handle those fine, because in a store procedure, you can drop create all day long, and it just doesn't matter. And you can do that with views also, but in the case of tables, we need to actually have diffs and add columns. And so in the update folder, that's where we can create any number of scripts that modify the structure of any particular tables. And then in our build script over here, we rebuild the database with a path to source database scripts update. And it just runs through in alphabetical order. That's why we number them. Execute the script first, execute the script second, all the way down 500, 1,000 scripts, doesn't matter. It's blazing fast. So however many scripts you need, it's just going to boom, 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 boom. Okay? And if it's already executed 999 and you add that 1,000, it's going to go through. It adds one little table to the log table, and it's just going to execute that one that hasn't been executed on the target database. Who got a hand? Mitch.
Is this accessing an initial design, or is 001 the first one you do?
Sure. So the create folder is where you would play. If you're starting on an existing database, you would script out everything in the database and put however many scripts you need in the create folder, and that would only be executed when you execute the rebuild command. So we would execute all the scripts in create first, then it would go over to update and execute those in order. For a brand new system, you typically don't have anything to bring in from the past, and so you can just start in the first script in the updates folder is the first table you happen to add, and the second script is the next table you happen to add.
What happens if you have a lot of scripts? Eventually, you have enough that it takes a long time.
That is conceptually possible, yes. I haven't found out what that number is. But conceptually, that's possible, but it's a sufficiently high number that...
How much test data you have?
So one of the tenets of this approach is that the test data set that a developer works with locally is only as big as necessary, and the test data sets that are appropriate for more exploratory testing are managed outside of the actual development process, because they do tend to take more time, more management. You got to sort of carry around this big set of data. But if you're in the development process, it's more of a functional and logic perspective. There is a test data folder where we can put in SQL scripts that do insert statements that put in just enough to run through the basic functionality. But yes, a separate process for the exploratory testing. Yes, sir.
Do you split the update script into sprint?
No. Well, by convention, the tool. So the tool doesn't really care what you do. It's just going to run them alphabetically. But what we do is just, oh, there's a number 2. Okay, the next one's going to be number 3. The next one's going to be number 4. We may go for 4 or 5 weeks without adding number 5, or we may add 15 in the course of 3 days. But we just keep on adding the numbers. Because this has, in source control doesn't really care when it was added. Git will take care of that. But you're free to label them however you like, because the tool is just going to run them in alphabetical order.
What I mean is, for trying to run a build, do you just build script since the last time update, or do you update all the script?
So it's going to look at the target database, and I'll show you. There is one table that's added, USD_apply database script, and if we select from it, you can see that it has a record of what scripts it's run. So it's going to check, have I already executed this script? Yes? Don't do anything. Go on to the next one. Until, oh, number 3. I don't see number 3. Let me execute number 3. And what it does is it actually looks at the SQL file, and internally it splits the SQL file on the word go, and then it runs each batch of statements in an ADO.NET transaction, so that if something fails, it just kind of aborts and puts it back since the last transaction and reports the error so that you can look at it. But
Just because you're doing it in Hibernate, if you did any framework, would you not do it?
this actually has nothing to do with ORM whatsoever. This is just command line and SQL files. This has, no.
No automatic migrations. Well, semi-automatic again. You can always say when you want it to go to.
Well, here's the key. Here's the key to migrations. Some tooling suggests that a machine can decide when it's time to add a particular column and what it should be. In our experience, it takes a human to actually decide how it's going to be done, and then once it's done, put it in a file, source control. It's not going to be lost. I think the automated migrations where at deploy time it reaches out, peaks in the destination database, and then generates the code that then it will subsequently run without your QA people getting a chance to object. That process, it's so tempting. Yes, I wish that would work, but we haven't actually. I think there's some extra challenges to get over before that's feasible. And so we've stuck with the approach that the only thing that's ever deployed in production is code that has been tested and run multiple times before. And the approach that it look at your production database and on the fly decide what it's going to do and then do it, that we haven't adopted that.
Do you know if App Farmer is still using execute schema in Hibernate?
I don't know. I've tried to use execute schema as well, but I found the same thing. Decide what to do and then do it without any inspection process. Let me go on because it's already 7:30. Let me blaze through here. All right, so we talked about the build. We have the private build that we run locally. We run the build locally, and if it passes, then we deploy, and the continuous integration server is going to run the integration build, and then we go on. All right. The build script is also responsible for doing all kinds of environment configuration, the database connection string, any config settings, environment variables, operating system settings if there are web server settings. So put all that in your build script. Again, it's just PowerShell. So just put it in there. Right? If you have a document that says create this environment variable, well, just write a line of PowerShell that creates the environment variable and stick it in the appropriate place of the build script. All right? So I've already gone through that, and let's go, and we're going to finish with this, software development lifecycle. All right. So, again, iteration 0 is geared to set up the foundation for a sustainable software project, so that we can just turn that crank and build features, build out our assembly line. The software development lifecycle has a lot of good ideas, and it's also a bad word at this point in time because it's associated with waterfall. So here's the waterfall steps: conceptual planning of a piece of software, then planning and requirements definition, then design, then development and testing, then implementation, putting in production, then operations maintenance, and then throwing it away, disposition, end of life. All right. So in waterfall, the problem was, in conceptual planning, you think about what you're going to do and problem solving and all that. But then requirements definition, that's when the problem started. We would do all the requirements definition before we would do any technical design. Then we would do all the technical design before we would do any development or coding. Then we would do all the coding, and we started to chunk that up to do some testing. And then we would wait, a whole year or maybe more, and then implement it as integrated and go into production. So the Agile movement, remember, the Agile movement said, no, that's too long. And Scrum came and said, do it more often, meaning do it every month. And we shrink it. And then people got really good, and they thought, you know what? This is actually better. And so then a month's too long for a sprint or an iteration. Let's go 2 weeks. And then people found the extreme programming practices and all the automation to allow us to go faster, and then some more sophisticated people said, no, let's do 1 week iterations. Forget this whole 2 week stuff. Let's do 1 week iterations. And then someone said, we're spending a whole lot of time doing this whole iteration planning, retrospective, iteration closeout. Do we really need all that? We're doing this 1 week. And so then someone said, well, why don't we just do it every day? And then somebody else said, well, how are you going to do that? And then somebody else said, well, wait a minute, look at Toyota and then this Kanban thing. And what we've done is we've gone from Waterfall, where we had huge batch sizes, where we batched up based on activity. Then Agile said, no, let's have shorter cycles and do all of these activities in shorter cycles, to now the state of the industry, the leading front of the industry, is really merged Scrum with Kanban, with extreme programming technical practices, and is really doing software with a batch size of one. One feature, one story, one change to the software. Beginning of project, you do conceptual planning and whatnot, but from requirements, you do the requirements for one feature, you do technical design, you do development, you do testing, and some people deploy it to production. Okay? So from Waterfall in the 90s all the way to the most modern state of Agile software development these days is a combination of extreme programming and Kanban, with a continuous flow through all of these stages with a batch size of one. And if you have, let's say, 4, 5, 6, 10 people on the development team, a what they call a work in process limit of n, which is if I have 5 people, then I will have 5 things in progress, meaning one person, one thing in process. Okay? And so from a software development lifecycle perspective, these things are important to establish when you're starting a new project. You're laying out the technical things, but the process for how to turn the crank and how to build it is really important. And I found one aspect that changes the game. Because if we end up with our first release and the stakeholder says, well, that wasn't what I meant, then we've got some problems. If the stakeholder says, yes, that's what I meant, but why does this screen keep erroring out? It doesn't work. We've got some problems. If we try to go to production and it's really slow, we've got some problems. So that we can have problems every step of the way. And the problem I see, even in shrinking the batch size down to 1 and doing Kanban with the same software development lifecycle, is that the notion of quality assurance is still left to right before deployment. It's the notion of QA, the notion of the test team or test function is, okay, we've got some software that we want to deploy to production, and if the test people say no, we're all mad at them because they were the last gate, and we all wanted to go to production, and now they found something and they said no, so they're the bad guys. But organizationally, they might say no because a screen's broken. Okay, maybe there's a technical bug, or the screen doesn't do exactly what it needs to do. Maybe there was a design and analysis bug where what if a field is missing? Yeah, when the developer's fault, it was the person that was kind of coupling up the need to what fields need to be on that screen, right? That happens. And so the notion of QA still needs to fundamentally change in our organizations to really set ourselves up to turn that crank fast and not look back and never get into walking through the mud. Because this is what happens. If we continue to leave QA till the end, then we have a function that catches problems. And when they catch problems, we have one backlog of stuff that needs to be done, that needs to run through our swim lanes, our Kanban board, moving cards across the wall, and then the QA group starts up their stuff when it's time to release, or we get to a certain point down the road, and we're working on the developers are working on other things, and then they come and they start creating a second backlog. It's called the bug list, right? So now you have bugs putting in here, but you got folks creating features, and now this other backlog of bugs, and so you have 2 streams of work. And now we have to figure out a process for prioritizing together 2 streams of work, and then some teams find themselves in a process where literally and I've heard this, literally they say, yeah, we're doing a bug iteration. Anybody heard that term? Or we're doing a bug sprint, right? It's because we got ourselves into this situation, and we don't have to. So if we take the concept of quality assurance, and we say, okay, quality is a mindset, not a step, right? And once you already have the code and you want it to deploy it somewhere, you can't really assure quality. You can only detect the lack of it, right? So if we take the concept of quality assurance and we bring it to the front of the cycle where we're doing that planning, where planning meets requirements definition, where a little bit of wireframing or showing a picture of what a new screen will look like, or the logic or flow of a new feature of a new story, and we take and we say, okay, before a requirement, whatever document format you happen to use, whether it's TFS, Jira, a Word document, whatever, however you write it down, a requirement that hasn't had the technical details put into it, before that's allowed to be started on, there are quality criteria that must be met. And if you have a QA department or someone in your organization whose job it is to do that, well, you can assign it roles. Who's heard of done, done, done? The definition of done, and it's all these things. But it's still right here. Done, done, done. Instead, it needs to be done, done, done. Right? So start going through that first done checklist here before we even allow anybody to do the technical design. And let's do a quality control checkpoint on this step first. And let's kick back requirements bugs immediately. Right? Next, now goes into technical development. Same software development lifecycle that we've been talking about for a long time, right? We're just batching it up, smaller batch size of 1, using Kanban, work in process to just funnel things through, turn the crank. So it's all the same steps. We got a batch size of 1, do quality control on the requirements, kick it back if there's a bug here, and instead of filing a bug in a defect tracking tool, instead, just mark it not done. Don't let it progress. Because once you let it progress to the next step, now we're hosed. Because now we have a second stream of work. Instead, let's stop it from progressing, and it precludes us from having this second stream, this second backlog that then later on has to be prioritized in. So check for requirements bugs here. Then we do technical design. Have a checkpoint, define a checklist for what technical design done means for technical design, and do a quality control checkpoint here. Now, when you're looking at the technical design, you may have some problems, and you may discover that you missed a requirements bug. Okay, take that and put it back here. Instead of saying, oh, well, now there's a bug in this story, let's just put it back to this spot in the workflow. And just consider it not ready to go forward. Yes, ma'am?
Who is responsible for doing QA or QC to requirement definition or even the architecture?
Well, in your organization, you're just going to have to pick the people. I think that's something that your organization will have to figure out. And if you've got a small number of people, then you're already having the same person wear multiple hats, I'm sure, right? But you're free to pick anyone. But from a process perspective, if we let it flow all the way down here, then all we're going to do is find our problems later in the process. So we do technical design. Part of the technical design, by the way, should be to design. Sorry, part of requirements should be to decide how to test the software feature. And part of the technical design is how to design the test for the software feature. And then part of the development coding is writing the code that automates the test for the software feature that was developed. This is where full system tests come from. Okay, unit tests, integration tests, we can figure out those on the fly. But when we're analyzing how the feature should behave, is the right time to figure out how we're going to make sure that the feature behaved in the right way. So the requirements should include the definition for what test cases we're going to run, and that can be part of the coding. And in that way, all the functional defects pretty much eliminated, and we're just left with the exploratory side. And that way, we're baking in quality to every step in the process, because this is yet another way we can set ourselves up for avoiding the walking through the mud 6 months, 9 months down the road and doing these bug sprints. Yes, sir.
In your organization of 37 people, do you have dedicated QA people?
So there are a few engagements where we have it rises to the notion of having a person with a test role. That's really sort of a test architect role, someone whose job it is to oversee the automation test bed, but everyone in our organization participates in designing and writing automated tests. We bake it into the normal job description of every person writing code.
QA.
Right.
And who actually is in charge of making sure that each and every step is happening, so to speak, that you go from step to step, this gets completed?
Yeah, so this is an oversight type of role, engineering manager, just from a process perspective.
So your manager is doing all this.
I mean, it's not that once it's put in place, it's not really hard because the team sees, oh, this is our process, this is how we turn the crank, this is how we go fast. So, but putting it in place, yes, just like any process.
How do they actually see it? How do you have it, to show to everybody where you are at any particular time?
So we like Trello as a visualization of cards, and in some projects we do have a project using Jira. I think Jira and Trello are really our main two. But any and we have some people that are not in Austin, so we've got all our stuff online. But anything, there's a lot of choices now for visualizing. Essentially, columns of sticky notes on a board and moving things across.
Right.
But Trello, I think, is our current favorite.
Trello.
Trello. Right.
Trello is really good. For just digital and it's cardboard, it's really good.
Right.
The TFS also has that dashboard feature which shows progress.
It does. We tried that sometime last year, and there was something that was kind of quirky about it, and just being impatient, we turned to Trello, and I suppose at some point we should go evaluate, because they're really investing in Visual Studio Online. Anybody use TFS on premise right now? An installed instance of TFS? Nobody? A few people? Yeah, the hosted version, visualstudio.com, I think is and for us it's clearmeasure.visualstudio.com. It's got a Git repository hosted on Microsoft servers, and it's got pull requests where you can do a code review. They're really investing a lot in it, so I expect some good things to come in the next few years, because they realize that they need to invest more in it. They've been kind of lax in recent years. But this slide basically just has it codified. Supplement these with defining the test method, and design the tests, and code and automate the tests, and verify the tests, and when we're ready for deploy, run the tests, and then also execute deploy scripts. So again, iteration 0. Oh, by the way, these slides are in the Git repository on the GitHub repository, so you can download these along with all the code. Iteration 0 is the point where you can make the decisions that'll set you up for sustainable software, both from a architecture standpoint, software configuration management, and the building blocks of the right process so that you can have a sustainable flow. Because if you're on a one-year project, you don't want to get bogged down, and even if you're on a short project, you don't want the code to atrophy and be hard to modify later on. So I know there's a lot of information, but getting started well is so important. And there's a lot of challenges ahead. You don't want to shortchange the first process and then have to deal with it later. So I know we are. I think we're at time. I'll be hanging around, happy to answer any questions. You can email me. You can call me. This is my phone number, jeffrey@palermo.com or clearmeasure.com. with a hyphen in between, and be happy to answer any of your questions. And thank you so much for coming. Any final announcements before we adjourn? Right?
It's the hour of code week.
The hour of code week.
Yeah.
Tell them.
So anybody here, everybody familiar with the hour of code? Microsoft last year, I think they got it out to 20